Alright, hello class. Today we're going to be looking at lesson 9, which is on inequalities. Now, thankfully this particular section is not going to be anywhere near as intense as the previous one, but it's going to use some of the skills we looked at previously. Okay, so to start with, an inequality is basically like an equation, but you don't have an equal sign. So something like this, 2x minus, let's do plus 3, strictly less than 19. Okay, this is an inequality because, well, we don't have an equal sign, we have an inequality. Okay, so we solve it just like we do an equation. Okay, so we solve like an equation. Okay, the only thing you have to do differently is when you multiply or divide by a negative number, you have to flip the sign. So except you flip the inequality whenever you multiply or divide by a negative number. That's really the only difference, aside from how we represent the answer. Other than that, it's solved in exactly the same way. So we will, say, move the 3 over, right, on both sides, so that we get 2x is less than 16. And then once again we divide by 2 like we normally would. The difference here, if this were a negative 2, we would flip that sign, so we're not going to do that just yet, since we're dividing by a positive number. So dividing by a positive number, we just keep the sign the same way, and so we get that x is less than 8, and strictly less than 8. Okay? So once we get to here, right, there are a few ways we describe our solution set. Okay, one is like this, that x is less than 8. So all of our x's will be anything less than 8. Okay, the next way is on a number line. Okay, so we can represent this on a number line. Okay, so on a number line, if you remember, hopefully this is a bit of a review. So we have 0, and up here somewhere we have 8. Okay. Now, there are a couple ways to do this, but for one, let's talk about the fact that if x is less than 8, so then we need to ask ourselves, okay, can I let x live on this side of 8? All right, so what I'm trying to find is where can x live? Okay, so where does x live? Okay, and we can't let x be on the right of 8 because here we would get 9, for example, and if we plug that into our equation, we would be saying that, or inequality I should say, we would be saying that 9 is less than 8, which isn't true. So we can't live over here. But we can live over here because, say, if we plug in something like 0, we get a true statement. If we plug in something like 7 or negative 10, so we actually can live, okay, on the left side of 8. So we shade that in. Now, what do we do at 8? depending on the class and what the book wants you to do, it looks like from your homework it wants you to put a parentheses here at 8. Okay, so this might remind you of say interval notation, and the reason we are going to use the parentheses is because we want to also match it with interval notation. Okay, so what the parentheses means, the parentheses means x cannot equal 8. Okay, we have strictly less than. Okay, so in general, strict inequalities are going to give us parentheses. Okay, and less than or equal to's, right, where we're allowed to equal to, we'll be using brackets. Okay. Okay, so we're going to use the parentheses. Some classes you'll see we use open dots or filled dots. That will likely come up at some point as well. But for now, what we're trying to do is just match it. Match it to what our interval notation is going to be. Okay, and so once we have that, the interval notation, if we want to write it as an interval, okay, like we're used to, well, what x can be? Well, we can go all the way to negative infinity. Right? So we say, okay, negative infinity, we always put parentheses around negative infinity. We never put brackets around negative infinity. And we go out to 8 and put a parentheses. Okay, so this is the interval notation. All right. Notice it does sort of match what we have on the number line. Okay, I tend to like to do the number line first and then try to figure out the interval notation. On your homeworks, it looks like it's doing it in the opposite order. It wants you to do the interval notation and then give you the number, or give them the number line. But I'm a visual learner kind of person, so I prefer to actually see it, then try to come up with an interval. So if you remember, our intervals look like this. So the reason infinity and negative infinity always gets parentheses is because x can't actually equal infinity, right? It can just get larger and larger or smaller and smaller and approach infinity, so that's why we always use parentheses there. Okay, less than or equal to would give us brackets. So let's look at another example where we actually will introduce the brackets. Okay, here's another example. We have a less than or equal to here. And depending on how we do this problem, we might also introduce some negatives to deal with. So what I'm going to start with is, like I said, we solve these just like we do equations, right? So I'll start by moving my x's over to one side, everything else to the other. So I'll start by adding 4x on both sides and subtracting 14 on both sides. Okay. So what we end up with here, these cancel. The negative 9x plus 4x gives me a negative 5x, less than or equal to 15 minus 14 gives me 1. All right. So now we divide by this negative 5, and when we do that, we have to change the sign. Okay, whenever you divide by a negative number, like we're doing here, we have to flip that sign. Okay, so I'll just say over here, flip the sign. 2, negative. I always do it the step I divide. I cross it out and rewrite the new thing, just so I I keep it straight, so I don't forget it in the next step. So what we have here is that x is greater than or equal to negative 1/5. Okay. All right. So if x is greater than negative 1/5, so on our number line, Now, remember, this doesn't have to be perfect, but I'm going to put -1 all the way out here so that -1/5 is there-ish. Okay? Again, with a number line, it doesn't have to be perfect. You don't have to be super accurate. All right, but there we go. Okay, so we know that x is greater than -1/5. So that means x lives to the right, because greater than or equal to -1/5, that will include things like 0. 0 is greater than or equal to -1/5. But -1 is not. -1 is less than -1/5. So we will shade this side of the number line, and since we have a greater than or equal to, we put a bracket. Okay. How I keep that straight is I remember that this line here kind of gives us a bracket, right? That equal sign. Whereas a parentheses is curvy, like the, well, if you squish it, you basically get, or sharpen it, you get a strict inequality. Okay. Now that we have shaded our number line, we now have what we need, okay, to do the interval notation, because the interval, you just bracket -1/5, comma, and we go all the way out. So we go all the way to, in this case, positive infinity. And remember, infinity always gets a parentheses. We never let it, we never put a bracket around it, because x cannot actually equal infinity. But this is just our way of saying it goes on forever. All right, so once we have our inequality, like I said, I always like to do the number line first, and then that quickly gives me the interval. You could do it the other way if you like, but I like to see things visually first. All right, just me. Okay, so we also, approach these equations just like we do any other linear equation. We start by simplifying everything that we can, then start moving things around. So as I said previously, we basically solve these just like linear equations, okay? Just like them. We just change this sign whenever we multiply or divide by a negative number, and then we have an extra step to represent the solution set, because it's a whole set of x's that will work. Fair enough? So we start this problem by, of course, distributing this negative sign so that we get 6 minus x minus 5 is greater than or equal to 5 minus 5x. Right? There's not much to do on this side. Then what I'll do is I'll combine my like terms here. I'll get the 6 minus 5 will give me a 1 minus x is greater than or equal to 5 minus 5x. Okay. And now we're going to move our x's to one side, everything else to the other. And so I will move my x's to this side. There's a reason for that. You don't have to, but when you move your x's to this side, okay, what happens is the arrow, your inequality, points to the direction in which you shade. Okay, so it's a nice trick to quickly find the solution. Right, so we get 4x is greater than or equal to 4, and then we divide by 4 to finally get our answer, x greater than or equal to 1. Okay, so from here on our number line, if this is 0, this is 1. Let's take a moment to think about which symbol we'll give it. Okay, as I write my arrow, and it will get a bracket. Okay, so we get a bracket, and we're going to shade on the right. Okay, because if x is greater than or equal to 1, things like 2 will satisfy this equation, or inequality, but things like -5 won't, 0 won't, 1 will because we have or equal to. Okay? And so once we get to there, in interval notation, it will be bracket 1, comma, and we go all the way out to infinity. All right, like before, on a problem like this, say we have fractions that we don't like, we can multiply by a special number that will get rid of them all. So in this case, I believe 12 will get rid of everything, because 12 will cancel with 12, of course, with 6 leaving a 2, and with 4 leaving a 3. So we'll multiply everything. Remember, you got to do everything by 12. Alright, so let's multiply everything by 12. So I have 12 times x minus 6 over 4 greater than or equal to 12 times x minus 3 over 6 plus 12 times 7 over 12. Now, if I had multiplied by negative 12, remember we would have to flip the sign, right? That's what we have to do in the case of multiplying or dividing by a negative. All right, so we'll cancel what cancels. 12 cancels with the 4, leaving a 3, with the 6, leaving a 2, and completely with the 12. All right, so what we end up with now is 3 times x minus 6, almost wrote 16, greater than or equal to 2 times x minus 3 plus 7. Okay, let's get this straight here. I don't know what my camera's up to right now. Okay, so now that we have this equation, we're going to simplify as we have been and all that. Distribute, everything like that. Okay, so we're going to distribute this 3, we're going to distribute this 2, combine all of our like terms, move everything around, change the sign if we have to, all that. All right, so we'll get 3x minus 18 is greater than or equal to 2x minus 6 plus 7. Okay. All right, now let me combine my like terms here so that I get 3x minus 18 is greater than or equal to 2x plus 1. Okay. All right, now I'm going to move my x's over to the left side. All right, sorry for that jankiness. That's going to be the order of the day for this class, I'm afraid, until I get maybe some funding for a better setup. Anyway, subtracting the 2x on both sides, and then I'll add 18 on both sides. Okay, so we get here x is greater than or equal to 19. And there we go. That's that. We didn't have to divide or anything like that once we got there, but we did have to start with some crazy fractions. So from here, for our number line, not really drawn to scale, but the greater than or equal to gets a bracket, and x is greater than or equal to 19. So for our interval, we'll have 19 to infinity, a bracket for 19, a parentheses for infinity, and that is that. Okay, so for these types of problems, hopefully this is kind of refreshing your memory on them. You solve them just like you're used to. The only thing you need to be concerned about is if you multiply or divide by a negative number, you flip the sign, and then we represent our solution in two different ways, either with an interval or number line. Okay, some argue that this also represents the solution set, but it's good to get familiar with these as well, the graphical representation along with the interval representation. Alright, so next up is what's called compound inequalities. Now these come up from time to time, and this is where we trap x's between inequalities. And these come up, you know, fairly often. This is kind of an important thing when we start talking about domain or things like that. So the idea is we're trapping x plus 5 between 1 and 6, right? 1 is less than x plus 5, which is less than 6. Okay? We solve this just like we normally do. What we want to do is solve for x on the inside, but we make sure we apply all of our operations to all three pieces. So we solve, all right, instead of trying to get x on one side, we try getting x in the middle. So we solve by isolating x in the center by applying operations in all three pieces. Okay, so for example, this plus 1 wasn't here. To solve this equation, you would just subtract by 5 on both sides. And similarly, if this 6 wasn't here, you would solve this equation by subtracting 5 on both sides. So we have it all joined together in one piece. We're going to solve this by subtracting 5 in all three places. Okay, and we look to the center to try and isolate our x if we can. And if there are other x's floating around, we try to get them all into the middle if we can. I don't think that's as common, but in case it does pop up, that's what you're going to do there. So what you end up with is negative 4 is less than x, which is less than 1. Okay? All right, when we have a trapped compound inequality, right, a trapped inequality where x is trapped between negative 4 and 1, when we go to our number line, right, so here's 0, let's say here's 1, 1, 2, 3, 4, here's negative 4, and here's 1. Okay, x can be anything between these two values, right? X could be 0, x could be negative 3, x could be 1/2, but x is not allowed to be anything to the right of 1 or anything to the left of negative 4. Okay. Also, these strict inequalities, remember, give us parentheses. So when we set up our number line, we're going to have a parentheses at 1. We're going to have a parentheses at 4, and then we're going to fill in the values in between. Okay. So in these trapped inequalities, these compound inequalities, when x is trapped, we're not going to go out to infinity, right? We're going to be trapped between two values. So in interval notation, this will be negative 4 to 1. Okay, here's another compound inequality. So we have that 2/3 x plus 4 is trapped between 0 and 2, or 0 is less than or equal to 2x over 3, or 2/3 x plus 4, which is strictly less than 2. Okay. Again, we're going to solve this equation, or inequality, like we would an equation, by trying to get x all by itself in the center. So, a couple of things we could do. We could start by the fact that we have a fraction that we don't like. So let's multiply everything by 3. So we're going to multiply everything by 3. Okay, so we'll have 3 times 0, which is less than or equal to 3 times 2/3 x plus 3 times 4, which is less than 3 times 2. Right, I wrote that I'm multiplying everything by 3 specifically so I can show that the fraction there cancels. Okay, so 3 times 0 is 0. We now have 2x plus 12 is strictly less than 6. All right. Now, to solve 2x plus 12, we're going to subtract 12 from each side. So I'll subtract 12 in the center, on the right, and on the left. Okay, so my 12 cancels in the middle there, and so we get that negative 12 is less than or equal to 2x, which is strictly less than negative 6. Okay. Now, dividing everything by 2 is going to get just x in the center, and that's what we're looking for. All right, so I'll divide everything by 2. Right, and get negative 6 is less than or equal to x, which is strictly less than negative 3. Keep in mind, if this had been a negative 2x, you would have flipped both sides. Okay? All right, now that we have this, x is trapped between negative 6 and negative 3. So here's 0, here's negative 3, here's negative 6. Okay. Now, here's an interesting thing that can crop up with compound inequalities. This side has a less than or equal to, so it will get a bracket, and this side with the negative 3 has a strict inequality, so it will get a parentheses. All right, so negative 3 gets a parentheses, negative 6 gets a bracket, and we fill on the inside. Okay, and once we have that number line, the interval follows accordingly. Okay, so the question then becomes, well, where in the world does this pop up? Okay, and I will show you, of course, but in this section, the remainder of what we talk about in this section are absolute value inequalities, and these can be pretty important when we're talking about domain and things. So what we're going to talk about is absolute value inequalities, and these compound inequalities show up in half of those cases. Okay. All right, I had a bit of a camera hiccup. I don't really know what's going on there, but yeah, so for x less than or equal to negative 5, for this particular piece of the inequality, this less than or equal goes to a bracket, and that x shades this side. Okay, so when we want to put that in interval notation, since we have two pieces of the inequality, two pieces on the number line, we set up our interval notation like we had before, right? 5 to infinity is one piece. And then we also have this negative infinity to negative 5 piece. And when we put them together with a union. All right, and what a union is just a way we have to join two intervals together. Okay, so now that we have these ideas intact, we're going to extend them to when we have anything in an absolute value. Right, so if the absolute value of whatever is less than or equal to 5, we'll say that this whatever, this u, is trapped between negative 5 and 5. And if we have the absolute value of this anything u is greater than or equal to 5, we have two inequalities to solve. One where u is greater than or equal to 5, or where u is less than or equal to negative 5. Right, both introduce a 5 and a negative 5. But in this case, well, we have u trapped in between, and here we have it as two separate inequalities. So let me show you an example where you might take a look at this. Okay, let's take a look at this example here. We have the absolute value of 2x plus 2 all over 4. Now, before we do anything, what I'm going to apply is I have the absolute value of stuff is less than 2. So when I have the absolute value of stuff is less than 2, that stuff is going to be trapped between negative 2 and positive 2. All right, and once I have that, I'm going to put that stuff in between. So this 2x plus 2 divided by 4 is trapped between -2 and 2. And from here, we solve this like we do the other one. So if you wondered why I didn't do many examples with compound inequalities, it's mainly because, well, when we do examples of absolute value inequalities, they come out to be a compound inequality. Okay? So in this case, since I have this fraction I don't want to deal with, I'm going to multiply everything by 2. Okay, so I'll just say multiply everything by, or sorry, not 2, 4. That will get rid of the fraction. Okay, so I'll write it out. 4 times -2 is less than 4 times 2x plus 2 all over 4 less than 4 times 2. And what happens here is the 4's cancel. I'll also mention if this were a -4, we would have to switch these signs, but thankfully we don't have to do that. Okay, so what we end up with now is -8 is less than 2x plus 2, which is less than 8. Okay. Now we go about solving this like we have before. We want to isolate x in the center here. So first I want to move this 2. Just make sure I do it in every piece. Okay. So we get the -2's will cancel in the center. -8 minus 2 is 10, which will be less than 2x, which is less than 8 minus 2, which is 6. And now we can go through and divide by 2. Okay, so when we divide everything by 2, we get 5 is less than x is less than, oops, sorry, that's a -10, my bad, that's a mistake. How I knew I had done something wrong is I got a statement that didn't make any sense. I had that 5 was less than x was less than 3. Now that doesn't make any sense. But when I have -5 is less than x is less than 3, now we're in business. Okay, so on my number line now, here's say 3, here's 0, here's -5. Both of these are strict inequalities, so they get parentheses, and we shade in between. And our interval is set up the same way. It's -5 to 3 with parentheses. Okay, so that's how we do an absolute value inequality where we have the absolute value is less than a number. Let's look at one where we have the absolute value is greater than a number. Okay, so here we have 2 times the absolute value 2x minus 9 plus 10 is strictly greater than 12. Okay, like always, our first step is to isolate the weird thing. Right? We want to isolate the absolute value. That's always going to be true, right? If we have some weird thing in our equation or inequality, first thing we want to do is isolate it. So remember, we moved the addition and subtraction stuff first, then we worried about the things that are multiplying. So we'll move this 10 over to begin with. Okay, and that will cancel there. So I have 2 times the absolute value of 2x minus 9, okay, is greater than 2. All right. Then we want to isolate this absolute value of stuff, so we're going to divide both sides by 2. All right, and it actually cancels on both, and then we're left with the absolute value of 2x minus 9 is strictly greater than 1. Once we get here, it is now 2 separate inequalities. We don't trap this between things. Now it's the 2 cases. We have our standard 2x minus 9 is greater than 1. I'll put this implies. Or 2x minus 9 is less than -1. Okay, so we're still introducing a plus minus, But remember, when we introduce the minus, we have to flip the sign. That's essentially what's happening here. All right. Now, we're going to solve both of these with the same steps. We're going to start by adding 9 to everything, because we want to isolate our x. All right, so I get that 2x is greater than 10 here, or 2x is less than 8. Okay, and then we're just going to divide by 2 everywhere. Okay, so the 2's cancel, and so then I get x is greater than 5, or x is less than 4. Okay? So I've seen people do this before, and it's actually wrong. You can't actually say this. This is bad notation. It leads to possible mistakes. I wouldn't recommend it. It's better to just set up the separate inequalities, even though you have to do the same steps and everything. Okay, it's just it leads to things if you end up, it just leads to weird things. So I would not, don't do it. But on our number line, we just add both. We have that x is greater than 5, so let's put 5 here. And we have strict inequalities, so we'll have a parentheses. So x greater than 5 is here. And x less than 4, well, 4 is right here. And we'll have all this. Okay? So when we convert this to an interval, we go from negative infinity to 4. Okay, then we go from 5 to infinity. Don't forget to put your union in between. That's like our addition for intervals, essentially. That allows us to join two intervals together into a single interval, even though there's a hole in between. Okay? So there we go. That is how we do an inequality with an absolute value greater than a number. Okay? Let me do one more of this type. Since we did a few compound inequalities, this is the one I think trips people up a little bit more. Okay, so for this example, it looks like we're starting with a less than, right? But remember, the first thing we want to do is isolate the absolute value. So notice, we don't distribute our numbers. This would focus. Right, we don't distribute our numbers into the absolute value. That's because that's going to do some weird things. We don't want to do that. The absolute value forces things to be positive. We can't reverse that to get some negative value. So instead, we're dividing things through. So consider this just a weird thing we want to isolate. We can't distribute across like we do with normal parentheses. All right? So we'll divide both sides by -2 to isolate this absolute value stuff. And what do we do when we divide by a negative number? That's right, we switch this sign around. So now we have the absolute value of 8 minus x is greater than 3. Okay? And when we have the absolute value of this stuff is greater than a number, that splits us into two separate inequalities. We have this 8 minus x is greater than 3, or 8 minus x is less than -3. And we solve these the same way we do the others. Okay, we're going to start by moving the 8 over everywhere. So we'll subtract that 8 everywhere. Minus 8, minus 8, minus 8. The 8's cancel where they do. Okay, so then I get x is greater than -5 here. Or x is less than -11 here. Okay. Now, to finish this off, since we have a negative x, we're going to divide everything by -1. Now, when we divide by -1, we have to swap the sign. So we're doing it twice in this problem. Okay. So what ends up happening is we get now that x is less than 5, or x is greater than 11. So on a number line, let's say 5 is here, 11 is here. Notice I'm not actually doing these to any kind of scale. I'm just, you know, doing it. X is less than 5. Well, that's going to be to the left of 5. And then x greater than 11, that's going to be to the right of 11. And so we have everything from 5 to 11 as our whole, and these pieces being what our x's can be. So transferring this to an interval, I'm going to have negative infinity to 5, parentheses, union 11 to infinity. All parentheses because we have strict inequalities. Okay, so that is how we approach absolute value inequalities. All right, and that should just about do it for this lesson. Let you approach the homework. We will use this a little later and some of these ideas as we go along. But yeah, so not as, hopefully not as unfriendly as the previous lesson. And be back next time with the next lesson. Okay, cheers.